morning, students. Welcome to online chemistry class of class 10. Today we will do chemical properties of carbon compounds. This carbon compounds, as I said earlier, all the compounds of carbon excluding both the oxides of carbon, that is carbon dioxide and carbon monoxide, and also the metal carbonates or bicarbonates. Leaving this, all other carbon compounds are listed as organic compounds, or nowadays these are called compounds of carbon. We will discuss some of the chemical properties of this. Now, in our syllabus of class 10, we have the reactions, combustion, we have oxidation, as well as we have the addition and substitution reaction. So the first reaction, what I'm going to explain is combustion. You know that combustion is actually a reaction in which the substance reacts with oxygen or burns in oxygen to give carbon dioxide along with the release of heat and light. And in case it is a hydrocarbon or a carbon compound, it gives water also along with carbon dioxide. So all its allotropic forms of carbon, whether it is diamond or it is graphite or it is fullerene or even it is in other form like coke or charcoal or even lamp black, all these are coming under this allotropes of carbon, and they do react with oxygen, especially sufficient oxygen to give carbon dioxide. As all combustions are associated to release of energy in the form of heat and light and sometimes with sound, then heat and light are the general products. In case we take an hydrocarbon methane, with sufficient oxygen it gives carbon dioxide, water vapor, and of course heat and light. With ethanol or any alcohol also that burns in oxygen. Now commonly this alcohol is known as spirit. The spirit on burning with oxygen gives also carbon dioxide and water along with heat and light. And nowadays this alcohol is being used as a fuel. This is called power fuel or power petrol. That is, the petrol is mixed with certain amount of alcohol to increase its efficiency. Now, in case we have insufficient supply of oxygen or we have inadequate supply, in that case, instead of carbon dioxide, carbon monoxide is formed. This carbon monoxide is a colorless, odorless, and deadly poisonous gas. Carbon monoxide combines with the hemoglobin present in our body and thereby forms carboxyhemoglobin. This carboxyhemoglobin doesn't allow the oxygen carry by hemoglobin. That means the hemoglobins, which are the oxygen carriers and transports oxygen to various body parts, the tissues, and make the cells also active. By the formation of this carboxyhemoglobin, this passage or transportation of oxygen is hindered, and thereby this is a poisonous gas causing paralysis, or even a little amount, excess amount of intake of carbon monoxide could be a fatal, could cause even the death. Now coming to the activity 4.3, which tells that some of the carbon compounds like naphthalene, camphor, alcohol, all these are burnt, and which kind of flames do we ever observe? And if a metal plate is put above the flame, what is actually observed at the plate on cooling? Make it a point that if it is a saturated hydrocarbon, this will undergo a complete combustion with clean flame, that is the blue flame, which is also known as non-luminous flame. This non-luminous flame is mostly used in heating purposes or heating devices. Similarly, if it is an unsaturated hydrocarbon, we have we do not have saturated or excess amount of or sufficient even amount of hydrogen, in that case this carbon compounds burn with a yellow flame with lots of black smoke, and that black smoke is being deposited as the lamp black over the metal plate. So this is the way how we are actually able to identify whether the given hydrocarbon is saturated or unsaturated. The saturated hydrocarbons always burn with blue flame, while the unsaturated hydrocarbons burn with yellow or luminous flame. Thereby, luminous flames are always used to help out as a source of light energy. This is also known as sooty flame as it contains some unburnt carbon particles, while the blue flame is used as a heating devices and is called non-luminous flame. In activity 4.4, we will see that if this is the Bunsen burner and which is having air hole to adjust the oxygen quantity. In case we have any saturated hydrocarbon as a source of energy and it burns by adjusting the air holes, when we have sufficient oxygen, the flame is blue in color, as that is observed in gas burner, even the LPG gas ovens. And you have observed if the pores present in the oven blocks due to some of the reason, might be splashing of oils or any other materials. If the pores are getting blocked, then sufficient oxygen supply is no more there. The combustion of LPG gas is then incomplete, which gives a yellow flame along with the black deposition or unburnt carbon particles. The next reaction is oxidation. We have the activity, we have to take certain amount of ethanol in a test tube, which is a colorless species, and warm it gently in a water bath. The water bath means we are heating this ethanol in a container that is dipped into boiling water so that the temperature remains within 100 degrees Celsius. And if we directly heat ethanol, then it will get the complete combustion, and even if it will burn with a smell, a flame. The flame is being produced when any of the substance is containing either volatile impurities or the substance itself has a low boiling point, can itself with a little excess of heat energy turns to the vapor phase and therefore forms the flame. So however, to control the flaming or direct combustion of ethanol, this is being heated into the water bath so that the reaction temperature is reached or attained by ethanol, but at the same time it is not itself burning with the flame. There is the difference between combustion and oxidation. In combustion, the substance directly reacts with oxygen, producing heat and light, while in oxidation, we use some oxidizing agents or some species which are ready to produce nascent oxygen or newly formed oxygen. Bayer's reagent, or that is nascent oxygen, we are writing it oxygen O within third bracket. Potassium permanganate, potassium dichromate, all these are the, even nitric acid are the sources of oxidizing agent that produce the nascent oxygen. Now add a 5% solution of alkaline potassium permanganate drop by drop to this solution. This is purple in color, and when these two are being reacted at a little higher temperature, it produces an acid. Here it is called the acetic acid or ethanoic acid. Since ethanoic acid is colorless, so the purple color of potassium permanganate is being destroyed and it seems to be colorless. That means, does the color of potassium permanganate persist when it is added initially? No. And why does the color of potassium permanganate not disappear when excess is added? Because the reaction between potassium permanganate and ethanol. This is the source of nascent oxygen, just to convert the alcohol into carboxylic acid. In case we do not have sufficient ethanol and we add excess KMnO4, then all the alcohol present over there is being oxidized and excess KMnO4 will still retain its purple color. This alkaline potassium permanganate or acidified potassium dichromates, these are called oxidizing agents, and they can oxidize alcohol to carboxylic acid. We are not taking directly oxygen or O2 for oxidation usually. If it is the reaction, then this is called combustion. The next reaction is addition, which is a common reaction of unsaturated hydrocarbon. Unsaturated compounds means these are always having a double or triple bond. So there is a scope that if it gets hydrogen or any other species, then the double or triple bond can open up to form a saturated compound. Usually this unsaturated hydrocarbon to saturated hydrocarbon conversion is called hydrogenation or addition of hydrogen. This hydrogenation is done in presence of nickel, platinum or palladium catalyst at 200 degrees Celsius. And you know that some of the vegetable oils, which are called the healthy oils, because these are you might have seen that PUFA and MUFA are written over the brand of the oil, means polyunsaturated fatty acid or monounsaturated fatty acids. This light oils which are containing the unsaturated fatty acids, these are good for health because they do not allow the bad cholesterol to deposit in our arteries and thereby do not make the arteries walls thick, so that the heart has to pump more in order to purify the blood. So in that case we could tell that this oil which are unsaturated, this are being hydrogenated to get the saturated fat or called trans fat by this process of catalytic hydrogenation. And this trans fats or saturated fatty acids, these are stable compounds and they do not undergo rancidity, while the light oils, though is healthy for cooking, but they undergo quick rancidification, that is the undesirable oxidation or causing the foul smell or degradation of nutrient. The last reaction is substitution. It is the characteristic reaction of saturated hydrocarbons. These are quite reactive and inert in presence of most of the reagents. But in presence of sunlight, especially when chlorine is added, it goes a series of reaction. This is almost an instantaneous reaction in which one of the hydrogen is replaced by Cl. So the products are chloromethane and hydrochloric acid or HCl. This reaction is only observed in presence of sunlight, hence it is a photosensitive reaction. And the reaction is carried out in the process of chain as long as all the hydrogen of methane would be converted to or be replaced by Cl2 or chlorine, and finally it changes to CH3Cl, then one more hydrogen will be replaced to get CH2Cl2, further chloroform, that is CHCl3, and to ultimately CCl4 or carbon tetrachloride. Even that means always this chlorination process that occurs under diffused sunlight. At exposed sunlight the reaction rate is very high, but at diffused sunlight it reacts, and in dark also this substitution reaction does not take place. So however, when diffused sunlight is there and methane is allowed to react with chlorine, it forms a number of compounds. These all are the chloro derivatives depending upon how many hydrogens are being replaced by Cl. So it is a chain reaction, and number of atoms, a number of products are always there. Of course, the number of products are usually formed that with higher homologues of alkane, more will be the number of hydrogen present here. There will be more number of products to be converted it into the respective chloro derivatives. Please do complete up till this, and you know that only this much is there in your revised syllabus. So in the next class, in the live class actually, on Saturday, we will be doing the writing of some examples or nomenclature of functional groups, as well as we will be doing the practicing of writing the isomers of butane, pentane, and some other compounds too. Thank you. If you do have any doubt, please put it in the common official WhatsApp group. Thank you, children.